It's there.
But again, it is coming to me missing.
Farah, आपने देखा था? I've sent two, I think
Yeah,
yesterday. One I've sent
Yes,
today. I've sent all my assignments. You want it again? I can send it again.
let me, Dr. Nimrat, let me send her the link.
Thanks so much.
Yeah.
Is Urja has also submitted? For me, it is showing Dr. Nimrat and Urja have not submitted so far.
Ma'am, check click on Dr. Nimrat, you will find the document. It is showing missing, but when you click the name, you will get the document. Yeah.
Okay. And what about Urja?
Yes, I'm checking. She told me that submitting. Okay, Urja's assignment is not there.
Okay. So again, but it's still it is showing. I don't know why it is right. Okay, so document is there in Dr. Nimrat's, but not there is no document in Urja. But both are showing the missing. It is written missing over there, right?
Maybe they submitted late. That is why it's showing missing something. Something will
Okay.
like
Okay.
maybe a technical problem. Yeah.
Okay. Swati ji, hello ma'am. I am yet to go through the validity class. Will watch the recording tonight. Okay, sure. You may go by the recording, and if you have any sort of issue arising or you want to discuss anything, either you can contact in the class or you can also drop a text through WhatsApp or through Farah, or you can also contact me on my personal window. I am available over there. So, like for the fourth unit, we all are aware it is divided into two sections. Okay, so it is divided into two sections. One is questionnaire construction, and the other part for the norms. So I would be covering norms for you today, and in the upcoming later classes, sir would be teaching you the questionnaire part. I guess, Farah, have you like had a word with sir regarding this?
Yes, ma'am. Yes, ma'am.
Okay, so yes, so for upcoming 2 days, I'll be taking your norms, the classes on norms, and then later on, the questionnaire part would be taken by sir. So today we will be beginning from the norms. So before we begin with what actually the norms are, can any of you tell me what is norm? Before the norm, what is normality? What is normality? We discussed this in last class also, the norms, characteristics of good psychological test. Anyone? Who do you call normal? Like, are all of us are normal or we are abnormal?
Normal.
How can you say that?
See, defining normality is not very easy, but what they say is it's something, there are 4 Ds to define it. Suppose they are deviant, they are showing deviant behavior, then they say they are destructive, then we say they are away from normal. 2 more I have forgotten. There are 4 Ds actually.
It's all right. So, but the question of mine is why the normal, why we can call us ourselves normal? Don't we show certain sort of pathology in certain situations.
We so show, but if it is persistent and it is disturbing the people around us, then we have to think over it, whether it is really one time event or it is repetiting always. What is the and it is disturbing the same person, or the person himself also is being disturbed because of that. So that is also considered when we define normality and abnormality.
Okay, so when we define the normality, we come across a certain sort of norms when we say the
Ma'am,
normality. Yes.
yeah, sorry, I joined late. Is your
It's a,
question about normality and abnormality?
yes, my question was this only.
Okay, so as Varsha ma'am was saying, the four Ds are basically like what I understand is the normality and abnormality. It has a very fine line, and in many cases, we cannot exactly define what is normality and abnormality. But as ma'am said, that four Ds are there. First is deviance. If it is deviating from, like, on an average, whatever the culture has been set up, or whatever the average thing is, what most of them are doing, if someone deviates from that, that is considered abnormal. The second D is distress. So this is basically explaining the psychopathology, these days. So the next D is distress. If anyone is distressed uh, about whatever behavior they are doing, or any situation is causing distress for them or for others who are there. So deviance, distress. Then the next one is a danger is if there is any kind of behavior which can cause any dangerous situation for that person themselves or for the persons around them. And the last D is dysfunction. Dysfunction is if it is not functional, if any behavior is not functional and is not, it not is not getting the purpose fulfilled, like whatever the function is supposed to be, and that function is not being fulfilled, then that is dysfunction. But these are more in terms of the when we try to explain the psychopathological aspects or psychopathological behaviors. So that, again, coming on to the norm, like set norm, or when we say that when we talk about this in terms of psychometrics, I feel that norm in simpler terms can be so for example, if we are getting suppose I consider suppose, like, we suppose 10 people are there, and then we gave a test, and then we on that test all of us got some marks, right? So that will be just our marks, and we will not know that on in terms of a standard thing we don't know. So establishing the standard thing means that where do we stand in terms of, if we have suppose if we are doing giving this test, where do we stand as a whole, which means that uh, just our individual scores cannot explain that is like the kind of raw score. So we establish some norm, that this is the set norm, and that gives us some standard to compare our individual scores with, so that we can know that where do we stand in the whole world or in society.
Yes,
That's
so
it.
norms are, so thank you so much, Anjali. Though you will join late, but you were at to the point. So kudos to you for that. So yes, so all the D's you explained were correct. And the point mentioned by Varshaji was also right. Yes, we do have certain sort of pathology and we act in that way in certain situations, but we can't call ourselves abnormal because it is not intervening with our daily life activities. But when we talk about the norms, so norms are the standardized scores or the rules which governs us and which helps us to identify in interpretation where do we stand. It talks about our standing in the group, our relative standing into the group. So yes, that was true for the part. So so now today the class would be more on the part of statistically. So we'll be discussing the statistical orientation of what the norms are all about. So I hope you all are aware about the measure central tendencies. You have heard this term?
Yes. Yes.
Yeah. So, or we all understood what actually central tendency is? Like any idea related to these three terms, mean, mode, median? How this help us? Okay, so central tendency, somebody has texted on chat. Yes, Swati ji, okay, so you have heard this term, but I am asking you, what do you understand from the central tendency, the term? So it basically talks about the technique to calculate the average or the central position in a population or in a group of sample or in a distribution. It provides us a description about the overall performance and allows us as a researcher to compare one or more on the basis of that norms given to us. So what happens, like you all do, what like if you are able to identify the average score of a class, that would help you to identify how much your students are in the nature, whether they are top scorers, where they are like the average scorers. Like if all, if you identify the average of your class of any of the exam is 90%, you are getting an average of 90%, that says most of your students are scoring either like nearby to 90, and also giving you a chance that they are top scorers comparatively to other classes. If you get to know that most of the average students are scoring 50%, so that shows that 50% is like what the students capability is all about. So on the basis of averaging, on the basis of the central tendency, we are able to modify or to create our techniques or to skills on how to impart knowledge. So this is what central tendency has to do with all the statistical techniques. So we use mean, mode, and median, and that other concept is also known as the range is also there. So what the mean is, what mode is, and what median is. So you can see let me just drag this here. So all of you can see a small graph here. It is called a normal probability or the normal distribution curve. We'll be discussing it in the upcoming slides, but first we need to understand what is mean, what is median, and what is mode. So mean, it is usually said that mean is the average or the average value. How we can identify the mean? We can just need to add up all the numbers and divide it by the total number of observations. For example, if I need to identify the mean scores of the first assignment, uh, like you all have submitted and the scores received on that, and if I wish to identify the mean or the average scoring, then I would be doing totaling all your scores obtained divided by the number of participants. So that would be giving you the mean. Then comes the median. So median is the middle number between. So what we do, we for the median, we need to uh, arrange all the values in the ascending order. For the mean, no need to assign, no need to uh, put values into the ascending orders, but for the median we need to do so. And then what we do, we are supposed to identify which value is coming into the middle. So there are certain ways, we all have like read about all those techniques how to calculate median, but one of the simplest technique is when the value is in the even, or when the value is odd, we need to add plus 1 and divide it by 2. So this is the technique we use to calculate median in our school days. Then later on we get to know about the lower value, the frequency, etc. when we calculate it in the statistics format. Then comes the mode. So mode is the most occurring number or the most frequent number. So the number, the value which is occurring again and again will be the mode. The range says the what would be the lowest से highest के बीच का distance. So it is the difference between from your lowest to the highest. So that is known as the range. So for example, if I wish to ask what is the range of the scores received by the students, so we can easily say if some of you have scored 10 on 10 and if some of you have scored 7 or 8, and that is the least value and the highest value is 10, so the range would be 7 to 10, which would be giving you that this is the range, this is the difference between from where you are starting and from till where you are going. So these four values are considered for the central tendency. So now today we'll be understanding how the mean, mode, median, these all things are calculated. So because if we need to study norms, we need to understand what actually the normal distribution or how the raw scores are supposed to be interpreted. How the standardization takes place. So for that purpose, we need to understand what is mean. If in any point of time you face difficulty in like you want me to repeat, then please let me know, because this is a kind of mathematical and statistical part, and so you can ask me in the mid of the class also. So for example, if you need to identify the mean from for the following data, which says 6, 7, 10, 12, 13, 4, 8 and 12. So as I told you earlier as well, so this is the way you just need to totalize all the sum of all the values and divide it by the total number of observation. So this is what I have done so far in this PPT. You can also see Excel ka part has been cut it out for you. Then comes the mode. So as the mode says, the most occurring number, so it is most common value which is obtained in a set of observation. For example, अपने पास एक data है 373993518. So you like by checking this out, you can also say that which number is occurring the most. Which number is occurring the most in this value 373993518.
3 is coming, yeah.
It's very simple to identify 3, but it's like for a data set where I have mentioned like 249646628 2, so you can check out this program, right? I have like, because this is for the part of the first and there is this second one. So can you see which two digits or one digit is occurring more than once or more than two times?
6 and 2.
So is it possible that there can be more than one digit having this most occurring?
Yes, it can happen.
Yes.
This is
So
called bimodal or multimodal district data.
correct. But when we talk about the normal distribution, we say that it should be unimodal. So because why? That should be a single mode to be calculated. So for a distribution with a single mode, it is said to be unimodal. A distribution with more than one mode is said to be bimodal, trimodal, etc. Or in general, we call it a multimodal because it is having more than one mode. But when we talk about the normal distribution curve, it is unimodal. So only one mode is there. You can't have more than one mode for that. Then comes this median. The median is the middle value, as I told you. So this is the formula we usually use during our statistical procedure. So L is the lowest value, and these are the terms which are mentioned to you. H is the size of the median class interval. That is the class size of the interval. Class size, you remember, we used to identify from the range 1 to between the range division, how much the size of a class is there. We used to mention it by I. In some of the books you need to mention by I. Here is just mentioned as H, so it can be anything. And then F is the frequency in which median class the term is pointing out, so that frequency is used to be taken. N is the total number of observation, or that or the sum of the frequencies, total frequencies. And the C is the cumulative frequency which is preceding the median class. So these are we also call it measurement of central tendency as measures of variability. So when we talk about we have already discussed the range, we know mean, we know the variance. And so what are these variance and standard deviation? once you have understood mean, mode, median, so we need to understand what is this variance is all about. So variance is actually uh, the difference between the mean and the data point you are measuring. Okay, so it's talk about uh, how much it is varied from the mean position, from the average position. Whereas the standard deviation, which says that it is your like uh, more on the part of how much it has been deviated from one part to other, that is the subtractive, the difference wala part. Variance is saying the variation, where standard deviation talks about the amount of variation. So that's what the variance and standard deviation talks about. Henceforth, you need to understand how this variability. It says like if the mean, most of you like if a mean score of a class is coming 50, and if you have scored 60, so which says that you are 10 points away or forward from the mean of the class. And if you are like again average is 50, and if you are scoring 25, so that says you are below 25 points from, or below or varied this 25 as a varied, you have varied from that mean part. So that's how we measures, we talks about the variability. So now we will be talking about normal distribution. So yes, the normal distribution, normal probability curve, which says it is a bell-shaped, smooth, symmetrical, unimodal, continuous curve that peaks in the center and tapers on both sides as one approaches towards the tail of the distribution. So first thing, it is a bell-shaped curve. So it will be a bell, how a bell looks. Usually you can call it like a, it's a ulta wala U, inverted U. Okay, it is a smooth and symmetrical. What do you understand from symmetrical? What is symmetry? What do you think? What
Same or
is
equal on both sides.
correct? So if you cut it into half, or if you fold it, it would be as it is, would be as a covering each part. The unimodal part I have already talked about. The continuous curve, so it says the continuous curves, it goes to the infinity. It does not like getting touching to the axis we'll be seeking. And the peaks it at the center, like you have checked this out in this first slide. You can see it is the continuous, it is not ending anywhere. So it is continuous, and it is peaked, and it is getting taper on both the sides. So this is how the mean, mode, median lies when we talk in the normal distribution, normal probability curve. So you can check, here it is. So this is the peakedness. This the 99.72%, 95.44%, or 68.26% says how much area is covered between the deviations of the scores. For you can see here, you can see the mu. This term is called mu, and we call this as sigma. So it is the mean, and this sigma is your deviation. So we say that this mean is where everything is on the average part, and here on the positive part, and on your left you can check in the negatives. So if I take an example of IQ scores, we all are aware about the IQ scores, how we calculate it. MA divided by CA into 100. MA is mental age, CA is chronological age into 100. So if I wish to say a IQ of 100, so what would be the mental age and chronological age of the person would be? If I say IQ of a person is 100, so what would be the mental age and chronological age of the person would be? Too easy sa question.
Same. Both will be same.
Yeah, so that the person like where whatever the chronological age, whatever the biological age, if like you are 16 years, then you have the mental age of 16 only, then only that is being covered. So that's how we usually draw. and this is the 100. So those who are scoring more than 100 IQ, we call them, can any of you tell me what is the IQ score for the gifted students? Like after what IQ score you say the child is gifted or child is above average?
150.
140 plus.
So we have understood the Einstein wala concept also. And at what you call it for the low scorers, mentally retarded, intellectually disabled?
70.
Yes. Below 70.
Below 70. Earlier, the DSM-4TR had talked about the 70, but now DSM-5 has clearly mentioned it should be below 70, not exact the term. So this you can see here also. I can say those who are on the left part would be the intellectually disabled, or those who are on the right hand part side would be moving towards the what we say the gifted. So you can see most of the population lies in the part of the average. Like it happens with us also in our classes when we used to study, or even if you are into the academics, you can see those who are either scoring very high or who are scoring very low would be very minimalistic, and most of used to score in the average or the mediocres. The one who usually the topper was supposed to be 2 3 students, even the low grades were would be given to only 2 3 students. Most of the population lies into the part of this midwala, which is a mediocre area or the middle part, so nearby to the average. So that's what we have observed. So you can see this area from between 1 sigma plus minus 1 sigma, that is from minus 1 sigma and plus 1 sigma, the value, the deviation, the percentage is 68.26% of the population is covered. So the I calculate this whole area as 1 or the 100%. If the whole area is considered as 100%, then this much of area is covered by 68.26% of people. Is it clear to everyone how this area I am talking about? What area I am talking about? Yes or no? Because we'll be doing some calculation on the basis of this only.
Ma'am,
So is
please
it
repeat again.
okay? So what part you need to repeat?
Ma'am, this middle one.
Okay, so I say this sigma mu minus sigma. So this mu minus sigma is minus 1 deviation. I can say, na, you are just 1 point away from the mean, right?
Mm, yes.
Here you are just plus 1 point forward from the mean. So this is a plus 1 sigma, this is minus 1 sigma. So the distance between these 2 points is 68.26%. If I say the whole area covered by this is 100%. So you can easily see the 68.26% is covered by this whole mediocre wala part, whereas the population who is covering, if I talk about the individual part, so you can see this is covered by only 13.59%, and this whole chotu sa area is covered by 2.14% because it is symmetrical. So as it is same thing would be happening on the both the sides, but you can easily see the 68.26% is the major area which is covered by the average or the mean people, whereas there are very few people on the lower notes, very few people on the top notch scores, bit more between the mediocres and the top scorers. Same here, uh, some more what related to this, the low scorers and the average, and most part is covered by the average population. If I take an example of our country, so we usually say na the class groups, income class group. So there are the higher class people, the middle class, and the lower class. So what do you think? Who are high in the population? Higher, middle, or lower?
Middle class.
Middle class. Yeah. Most of us, now the middle class also has the division like high, low, and middle. Even the middle class is also having the higher middle class, the upper middle class, or middle class, or the lower middle class. Now this somewhat division has also been occurred, but we know middle class is much more when we compare to those who are very rich or who are very poor. So here we lie in between. And mostly why we are talking about these average people with these major population, because we are supposed to be taken care in the long run. Ultimately we have understood so far now, we middle class people are only one who are actually paying the taxes, isn't it? What do you think? Because most of the middle class people are uh, engaged in the service sector,
Yes.
right? Whereas if we like the we have three sectors, na, primary, secondary, and tertiary sector. That's so very basic wala cheez. I am not going to that. But if we talk about those who are top notch or very rich, are into the industrial area, they are the providers. They are not doing any service, they are providers. So usually have their own tax slabs. Majorly tax is collected from the middle classes, and that's why the major population is covered by us only. Okay, so these are the
Ma'am,
properties
I
of
have one question, ma'am.
please.
I'm back one. Yes, this
uh,
slide. Ma'am, what is the significance of studying as one standard deviation, second standard deviation, and third standard deviation? What what actually we draw or conclude with? What we try to find out exactly?
So we tried, see, you have understood the concept of deviation.
Yes.
So what do you understand from deviation?
Uh, Deviation means how much the value is away from the mean point.
Hmm. Okay, very nice. So if I say the person is plus 1 sigma away, that is, if a person is 1 point away from the mean, so
Hmm.
you are able to understand how whatever part you are given, like whatever thing is known to a middle class or a average student, that plus one wala bacha also knows that. So
Hmm.
let's take an example in this way only. If I say you as a student is standing here,
Hmm.
okay, and this is your class average.
Hmm.
So can I say this ki before, below this, everything whatever these people on who are lying on average part, you will aware of it, you are
Hmm.
aware of this, but
Hmm.
having plus one more advantage over it because you are here,
Yes.
you might be having something extra, that's why you are here.
Hmm. Hmm.
And those, if any of our classmate is standing here, so that means they have something these two extra from you.
Hmm. Hmm. Hmm.
So it is showing your standing with the group.
Hmm.
So if a person is standing here, so we can't we assume that the person is better than these two wala part.
Hmm. Hmm. Yes.
You are able to compare.
Yes.
Understood?
Hmm. Hmm. Hmm.
uh, shall we move forward or anything else to ask?
Yes, ma'am.
Okay. So this is the property. I already told you the mean, mode, median are lying together on the same platter. Then comes the under area 1. Like I told you 1, why we are calling it 1? This is a whole. So I call it a, if we talk in the percentage area, so it is 100%. Okay, the 100% area is being covered, and then if you remove the percentage, converting it into the numerals, then it would be the 1. The minus 1 sigma to plus 1 is 68.26. The same thing I told you in the last slide. 95.44 and the 99.7% is being covered by minus 3 to plus 3 sigma or standard deviation. Now the application part. Why this normal distribution you can use? So to determine the percentage of cases in a normal distribution within the given limits. Like if you are supposed to identify how many cases are being there, like the prevalence we need to study when IQ study or any of the clinical study, it happens. Like psychological attributes like intelligence, I have already talked about. And also it talks about comparing the distribution in terms of overlapping, like how much part is being covered by this much of population. And sometimes it happens, like I told you right now, don't you think that it is overlapping of knowledge for you? Like whatever all these know, you also know, like because you are standing here, you have this knowledge and also one more extra, so you have already overlapped or covered all these part in your life, and henceforth you are standing above the mean position, right? So that's how this overlapped talk about. So this is a small word problem for all of you. If you would like to give it a try, you can give it a try in the class or later on, whatever you suggest. So it says, given a distribution of score with a mean of 12 and a deviation of 4, we are assuming normality. What percentage of the cases lie between 8 and 16? What percentage of cases above score 18 and below score 6? Do you wish to do this
Yeah,
right now?
we can do it given the values are given.
So please, you can, like, you can do one thing, note this question. After class, you can submit the answer. Otherwise, we might lose time. Or shall I discuss this in the class right now?
We can discuss, ma'am. It's just the
Okay.
same
Okay.
values.
So tell me, Anjali, how would you solve this question?
Yeah, so as the mean is given and a
Okay.
standard deviation is 4. So
Hmm.
if one standard deviation would mean that a point of 4,
Correct.
right? So
Hmm.
if mean is 12, so minus one standard deviation would mean 8. 12 minus 4. And plus one
Correct.
standard deviation
Correct.
would mean 12 plus 4, which is 16, right? So
Correct.
so for
Hmm.
8, so 8 to 16 is basically trying to ask that minus one standard deviation to plus one standard deviation.
Very
So
good.
for any distribution from minus 1 to plus 1, the percentage is given in that graph. So
Yes.
68.26%.
Very nice. And
Yeah,
then
same goes with, like, maybe some other person can try. B.
anyone would like to try with the question B? Very easy question.
Yeah.
Anyone else for this? Or like apart from Anjali, anyone else would like to try in
Would it
their own
be
way?
so standard deviation 2 would be 4 then from 8 to 4, and the standard deviation on the other side would be 20 maybe, isn't that? Or is you have to take the proportions into consideration. First standard the sigma is okay, the second sigma also will be calculated accordingly.
Yes,
Yes.
similarly.
Okay, yeah, so would that be 4 then? Because it's 8, so
Huh.
minus 4,
Yes.
that is the deviation, no? So that
Hmm.
would be
Yes.
4 on the other side. 16 plus 4 would be 20.
Correct.
Yes.
That's the second sigma 2.
Hmm.
So now for 18, we have to calculate, like we have to do some
Hmm.
calculations, but like the concept is clear.
So isn't, don't you think it is also easy for you to calculate for this?
Hmm.
See, for example, if I would say
Yeah, this
this is
half of this, yeah,
so this is 12, this would be plus 4 would be
16,
16, again plus 4 would be, where's my
20.
mouse? Okay, would be 20, and you are supposed to ask, question
18.
is asking about above
18.
score 18. So the score would lie between the deviation of 16 and 20,
Yeah, half of it.
half of it.
Hmm.
So see, you can see the 16 to 20, the deviation percentage, you are aware.
Yes, so we will just have 13.59, half of that, and then
So
add all of it, and then that will be the answer.
correct. And then similar below score 8. Chalo below score 8 dekh lete hain.
6
So
is written.
yeah. So for example, you are again it here for 12 and this is 8. So below 8 you can identify
Below 6, I think, ma'am, it is written in the question.
6 or 8. Oh sorry, below 6. I'm so sorry for that. I misread that. So, okay. So below 6, you can easily add it. See, if this is the way by using the graph, the other way around is we used to identify the Z score, like because we are actually identifying. It is saying, given a distribution of score with a mean and deviation for assumed normality, what percentage of cases you can identify. So here the mean and etc. are given. So we usually use the formula is equals to Z is equals to x minus mu divided by sigma. You might have read this formula.
Yes,
No?
yes,
Yeah.
yes.
So x minus mu upon sigma, which says x is the score that you need to identify. Mu is the mean and divided by your deviation. In the same pattern, you can identify. The best way I feel like, see, x minus mu upon sigma is very quicker way when you are supposed to solve during the time of your objective types of questions. But when you have the normal distribution curve with you, then this percentage method is also very easy. So I'm glad that you all were able to understand this problem. So now the deviation from normality. So when, sorry, so when we say, because the normality is already saying you are maintaining the symmetry. So when the symmetry is missing, when there is a lackness of symmetry, then we call it as skewness. And then comes the kurtosis, which is known as the peakedness. Peakedness is how much of the slope it is giving, that is the kurtosis. And skewness is like how much it is like shifting toward left or to right instead of center. Like you can see the graph is in between, but in the left part you can see it is shifted to the left. In the right you can see it is shifted to the right. So it is not maintaining the symmetry. So henceforth it would be called as the skewness. And for the kurtosis, it talks about the peakness or the pointedness of the graph. For the skewness, so when the mean and the median fall at different points in the distribution and the balance is shifted to one side of the or the other. See, it is so easy to understand now, because for a normal probability curve we say mean, mode, median lies on the same point. But what if mean, mode, and median are like placed onto different parts? So the graph would be having a different shape. It would be shifted to any of the side. So that's what skewness talks about. So if the scores are masked at the lower side, the spread of the curve is gradually towards the right. Like if, see how the graphs are being drawn. Like if I would say, so where the scores would be higher here, where all the scores are stacked, like can you tell me where all the scores are lying, most of the scores are lying, or most of the people are lying?
On the left, on the lower
Right.
side, on the left side. Yeah.
Yeah. And for this graph you can see where the people are lying more.
Right side.
Right.
So because like if to how to remember all these, so you can see if you remember the x-axis and y-axis. So x-axis, when you go to the right, it was supposed to be in the positive. When you go to the left, it is supposed to be negative. So when the graph is stepper at the left end, at the negative end, it is known as the negative skewness. When the graph is and is stepper at the right hand side, which is at the positive end, we call it a positive skewness. That's very easy to understand. So when I am saying that most of my scores are lying in the left side of the graph, so which kind of skewness it would be? Most of my scores are lying in the left side of the graph. Which kind of skewness it would be?
Negative.
Positive.
Positive. Because when I am
Why?
saying most of my scores are lying into the left, see, that's what you only told me, Dr. Nimrit. Here the people are having the mostly scores, it is in the left side, and the slope is going down this side. It is in the positive
Okay.
side. It is
Okay,
called the
okay. Yeah,
positive
got
skew.
it, got it, got it.
Okay, so in the similar kind of question you can understand from the other part. So the formula to calculate this skewness is 3 multiplied by mean minus median divided by the standard deviation. Or also you can identify using the P90. P10 is the percentile color change. We'll be understanding in the later class. Then comes the kurtosis. So kurtosis, as I told you, the peakedness or the flatness of a frequency distribution. So leptocortic, mesocortic, you can see the image is clear to you all. So lepto, meso, and plateaucortic. So when it is too high, too much of peakedness, then it is what it is called. When it is too flat, then it is called. And then what is required to us is the middle part, right? Is it clear to us?
Yes, yes.
Right, so these are the very basic part I wanted to cover. So now we'll be moving towards the norms, what why the norms are talked about. So usually when we talk about the test, so there are two types of tests we take. One is the criterion reference test, and then we talk about the norm reference test. So what is a criterion reference test, what is a norm reference test? So the criterion reference test is talked about, it has usually has certain criteria from which you are to measure, whereas the norm reference test, you have certain sort of uh, like you have one standard through which you are actually uh, measuring or comparing. So here you can you see this picture? Can you identify which picture is this?
Mm. That Arjun and Dronacharya,
So
Pandavas
what
are
is
there.
what is happening?
Criteria is being put by Dronacharya that you have to put the arrow right into the eye of the bird.
Yes,
Nothing else it should strike.
correct. So here the criteria is given to you to identify for the testing purpose, whereas here it is a norm reference test. You can see the apple should be, or this should be equalized for the, if I say. So that's how to compare, like you have this reference point and then you are having the comparison wala part. So to rank student based on the test achievement, scores are given as rank, like we usually do, na, first ranker, second ranker, third ranker. Then these are called the norm reference test. So now norms, though we have studied in our last unit also, as I told you, we'll be repeating it again. So yes, the norms, it is usually used for the interpretation of our raw scores. What are raw scores? You understand the term raw score? What is raw score?
The raw scores are the scores which we individual people would be scoring.
See, why raw scores are called raw scores? Because they do not contain any meaning. Raw scores, by using the standard score available, the norms available, then only they gives you a meaning. For example, if you are scoring any of the uh, until and unless you have which says that this means that, you are not able to identify how much you are scoring. Like if you are on a Likert scale or any of the scale, if you are scoring any amount, you are scoring 20, what does it mean until and unless you seek from the manual, from the norms table given to you, that what exactly this score interprets to me. So like the intelligence test, raw scores, raw the sum of the credits for the set of items we say. Phenoms is a transformed score used for determining individual differences in behavior. Like we have discussed the ways, so here the ways is given to you for as a reference. So ways raw scores are transformed into scale score, and those scale scores are later on transformed scores, are actually the transformed scores. You have transformed it. The transformed scores are used for estimation of norms. It gives knowledge where an individual is located under the normal distribution again. Comparison of two raw scores, like it helps you to compare the individual differences, the two individuals. If for example, if Varsha ji is scoring 20, if Varsha ji is scoring 20 on 20 in a test and I am scoring 18 on 20, so we can compare both of us, like who is, like maybe Varsha ji is studying more and I'm not studying, right Varsha ji? It could be interpreted like this.
Yes, ma'am, it
Yeah.
can.
Okay, so that's what the norms help us to identify. So now the major part of norms, which is T scores, Z scores, stanine, age norms, grade norms. percentile, etc. we will be discussing. So we have already checked this, how the IQ scores are being distributed. This is what I already discussed with you earlier. So it is based on the principle of normal distribution. Normal distribution के basis पर ही we are discussing all these, and we'll be discussing Z scores at the unit of normal curve, then the T scores, canine, percentiles, percentile norms, standard score norms, age norms, and the grade norms. So first we discuss about Z score. So like we calculate, I told you the formula Z equals to X minus mu upon my sigma. So that Z is your standard score, na? That's what we were identifying. So Z score is the number of standard deviation units a given raw score is above or below the mean. It is used to compare individual performance with respect to the group performance. So like I have already given to you, X minus mu upon my sigma. That is, X is your score. If I say X is your score, mu is your mean. Like I told you, mu is called mean and sigma is your SD. So this is how the Z scores are being calculated. So what are Z score? Can any of you tell me what are the Z scores then? Aren't we identifying in the word problem? Hello. Like if I say, when we were talking about this in this question, right? So were we identifying the Z scores as well here?
Yes, we can calculate Z score, and then we are actually calculating Z scores only in telling, no?
How? We were to asking about the percentage of the population.
Percentage, yes, then percentage, they see,
Hmm.
it is asking percentage,
Hmm.
but what we are doing, there is a score,
Hmm.
and the mean is being given, okay,
Hmm.
and standard deviation is being given.
Hmm.
So if we have a Z score, with that we can find the score. We have got a standard chart, okay, that this is the thing which would happen, okay. So based on that, we will have a Z score. So putting on the values, we'll find out how much the score would stand, or how much percentage of this score would match to this much Z score.
So what? Why
So
it is?
so again, that is what, na, then we are actually seeing how much percentage has come up. What was my score? What was
Huh.
my score? And that was the question. That was the question. They are saying that how much people would be there who would be scoring around this much.
So like instead of percentage, can you tell me in the terms of scores, in the terms of deviation? If
See,
I wish to
mean would
say,
be 12. See, mean would
huh?
be 12. Here,
Hmm.
this mu point would be 12.
Okay.
So first standard deviation would be 12 plus 4.
Okay.
16
Hmm.
point would be here.
Hmm.
Okay.
Hmm.
So if the person's Z score comes as 16,
Hmm.
it as 16, okay,
Hmm. Hmm.
and then I'll put X score.
Hmm.
I have to find out. 12 would be the mean which I'll put up, and then 4
Hmm.
standard deviation I'll put up.
Hmm.
If
Hmm.
I calculate it mathematically, I'll get the percentage of score that would fall here.
That would be the one deviation you will get.
Hmm.
If you put 16
Huh.
as your score, you said 16 as your score as X,
Huh.
right?
Yes.
Minus mean is your 12, dividing by 4. So 16 minus 12 is 4. 4 divided by 4, it is 1.
Hmm. Yes. See, it will be one standard deviation because this is the Z score for this point. Okay.
Hmm.
If I
Array,
move little bit less
okay.
onto the left side, suppose 1 point here. So there would be a
Hmm.
different Z score there. Okay. So then the value of that point would change. Score would change.
See, actually, why it is happening? Because we are just one sigma away.
Hmm.
Why we got the value 1? Because you were just one deviation above. You told the score as 16.
Hmm.
If I would have talked about if I would have said ki the mean is 12, the deviation is 4, the score I am getting is 20. Then
If
so
20
so what
then
would be the Z score?
score is 20. Yes,
Okay.
score is
Yes.
20.
So yeah, I am. See, my mean was 12,
Hmm.
and my deviation is 4. I am scoring 20.
So
Class
20,
का mean 20 है. हाँ, बताइए.
20 minus
Hmm.
12 would give you
Hmm.
20 minus 12 by 4 will give you the Z score where they would be standing there.
The 2.
Hmm.
This answer would be 2. So which says that the person who is scoring 20 is 2 points above from the mean,
Hmm.
right? If
Right.
a person is scoring the 20, then similarly, if a person is scoring 18, what would be the deviation? How much points it would be away from the like mean? You can identify using this
Yes.
formula. So I hope now you are able to like for everyone, not only the virtual, because virtually is actually participating. So I hope this was clear to all of you. So that's for the Z-score. So Z-score, it has two disadvantages because we are discussing the each scores also. So it is half of the scores are negative because again it will be going into the other direction also, and scores are expressed as decimals. Usually when you are able to identify the Z scores, we'll be doing certain word problems also. I'll be giving you in your assignment, then you will be able to identify how the decimal values are being covered. Then comes the T scores. Farah, do we have time to cover these other scores as well? These questions, बहुत सारा है. Hello, Farah. Shall we continue if you have like at least a T score we can discuss today? Or we need to conclude? Any of you can tell me yes or no would work. Otherwise, because you might be having some other assignments lined up.
Yeah, actually, I have to go somewhere, so can we wrap
I know.
and discuss these?
Sure. Okay. So today, I let's just conclude this here.
Hmm.
Okay, don't worry for that. We'll be discussing the T scores, Stanine scores, the cumulative frequency. We'll again be learning how we can calculate the cumulative frequency in real, and the how T scores are being interpreted, how you can identify the T scores in our next class. So, shall we conclude this today here? If you have any question, you may ask anyone. I hope you were able to understand the norms part today, and you like this also. Any questions from anyone? Sukhsiddhi, Anjali, Swati, Varsha, and Dr.
Mm,
Nimrat. Okay, so that was all from my end. Thank you so much, everyone, for the class. One thing I really wanted to mention is please kindly try to submit your assignments within stipulated time. Though I know you all have certain sort of other commitments going on, but still, uh, like I'll be checking the assignments one by one, but there might be a small deduction because of the late submission. There is that would be, otherwise it won't be justified with those who have submitted on time. Okay, so that was all from my end. Thank you so much everyone for joining. Bye bye, take care.
thank you, ma'am.
Okay.